In this video, we're going to add further to our look at code quality issues when designing classes. And the subject of this video is the idea of cohesion. Cohesion refers to the number and diversities of tasks that are performed by a class, a method, or even at the level of a package. So we can refer to each of those elements as being a unit. And what we really want to aim for is something called high cohesion. And that is when a class or a method or a package is devoted to fulfilling essentially a single logical task. And when it's doing that, we say that that has high cohesion and that that's a desirable property of the class, the method, the package, stroke module. So when we're assessing the cohesion of one of these units, we look at a class and we say, well, how many entities is that class modeling? Or when we look at a method, how many tasks is that taking responsibility for? Or could it be passing off some of that responsibility to other methods? And when we look at the classes within a module or a package, we look at how interrelated they are. Are these classes all related, essentially supporting the same set of tasks, or are they quite diverse? And what we'll do is we'll look at examples of all of those unit levels and see where we have high cohesion, low cohesion. So a class should represent one single well-defined entity, and a method is responsible for one and only one well-defined task. So let's take a look at examples of all of those unit levels and see what we mean by high cohesion or low cohesion. We'll start with the idea of looking at method cohesion. Here's a familiar part of the World of Zuul project, and this is the version of the print welcome method that we started with. We actually did some refactoring on this method in order to avoid some code duplication issues. But we can also look at this method from the perspective of cohesion. The method is called print welcome, and it clearly prints a welcome message at the beginning, welcome to the World of Zuul, and so on. It then undertakes responsibility for printing out details of the current room, the description of the room, what the available exits are, and so on. So in effect, it's undertaking two distinct roles: the printing of a welcome message and then the printing of details of exits from the current room. The printing of exits from the current room is something that we'll want to do over and over again. So really it shouldn't be located in the print welcome method anyway, because we're probably going to find it located elsewhere. And really it's not a prime responsibility of the print welcome method. If we now compare what we've described as an uncohesive version of the print welcome method to this new version, which is where we ended up in doing our refactoring earlier, we can see that essentially the print welcome method is printing a welcome message, and then all other tasks required at the beginning of the game have been devolved to a separate getLongDescription method here. So although we do still have the fact that the print welcome method is arranging for the exits to be printed, it's not actually taking responsibility for that task. That's been handed over to a separate method, which is again a highly cohesive method, getLongDescription, whose sole responsibility is to provide details of the room's description and the exits and so on. So we've transformed an uncohesive method in the original version into one that's much more highly cohesive, whose essential task is just printing the opening greeting for the game. Let's now consider lack of cohesion at the level of a class. At some point within the development of the game, we're probably going to want to add items to rooms. Players will move around the rooms, they'll collect items, and they'll probably undertake tasks related to the items. The question then arises, how do we manage the existence of items within the game? And an immediate thought might be, well, items belong in rooms, so we'll give responsibility for item management to the room class. And we might begin our development of that aspect of the game by adding a couple of fields to the room class that allow it to record an item name and an item description. Associated with that, we're then going to be adding item-related methods. For instance, the ability to add an item to the room takes the parameters for setting the item name in the item description field, and then probably a method to do with retrieving an item from the room. So a player says, I want to take a particular item, the room checks to make sure that the room contains that item, and then removes it from the room and tells the player whether they've succeeded in taking the item or not. In effect, what we're now doing is we're diluting the nature of the room class. It's now becoming a class whose responsibilities are both managing navigation around the game and also managing an item that might be located within the game. So we've muddied the waters as far as the identity of this particular class. A further issue is actually it's going to end up limiting the way in which we can exploit the existence of items within the game. So at the moment we're anticipating that a room might contain a single item. We're also anticipating that an item consists purely of a name and a description. Suppose we wanted to add other characteristics to items. For instance, they might have a weight, or they might have some kind of property. If we want to have multiple items within a room, we're probably not going to be multiplying item name and item description fields. We're going to want to go for some kind of data structure. And if we're keeping the elements of items separate in the form of names, descriptions, weight, powers and so on, we're going to end up with a huge number of individual data structures within the room class, and the class suddenly becomes really bloated and inappropriate as a loosely cohesive class. So really we want to rethink that plan to locate all of the item details within the room class, and in fact we will probably want to create a separate item class that then takes responsibility for the management of items, allowing the room class to retain its original characteristic of simply being concerned with the description of a room and its connection to other rooms and so on. So this is an example of an uncohesive class. We want instead to have separate classes for a room and an item, and that will allow much greater flexibility in the overall design of the program. If we consider now package or module level cohesion, the java.util package is a classic example of an uncohesive package. If we take a look at the classes within the package, we see things like collections and lists and maps and queues and so on, and that's fine. This is clearly a package that contains classes to do with collecting objects together. But looking further, we see we've got things like calendars and dates. We've got a random class as well. And those classes have absolutely nothing to do with collections like lists and sets and maps. So the java.util package is in effect a general collecting place for all of the classes that nobody could really think of anywhere else to put. And one of the problems is that because this design was in the package from the very early days of Java, it's now impossible to back away from that and to split off each of these classes into separate, more highly cohesive packages. So there's a legacy there of uncohesive design thought that we just have to live with for the rest of Java's life. Aiming for high cohesion, therefore, we'll find it much easier to understand what a class or a method does. And because it's doing one overall logical task, it's much easier to ensure that the logic of that class or that method is correct. There's not the potential for interference from the requirements of different elements within the class or the method. It allows us to pick variable names, method names, class names that are more clearly descriptive of what the overall task is that's being achieved by that particular unit. And in fact, it makes it much more likely that we'll be able to use a class or a method in either the same overall program or potentially in later programs as well, if it's a self-contained unit that isn't mixing responsibilities for all sorts of different things. In contrast to high cohesion, in loosely cohesive units we have methods performing multiple tasks, as we saw in the print welcome method. We have classes modeling multiple entities, as we saw in the room class, trying to model both rooms and items. And classes have no clear identity. What's the purpose of this class? Well, it's got multiple purposes. It's much better to go for a design where each class has one real clear intention. And then we have modules and packages of unrelated classes, with java.util being a classic example of an uncohesive package. So we aim to avoid loosely cohesive classes and methods and packages. So it's important always to be thinking ahead, and when we're designing a class, we try to think about changes that are likely to be made in the future. When we think about adding new features to a class or to a method, we need to think about whether this is adding to its existing responsibilities in a consistent way, or whether we would be better defining a separate method or a separate class, potentially uniting the functionality of now those two separate methods via a third method, or those two separate classes via a third class that's going to coordinate the instances. Of course, this requires a little more effort at the point where we want to start introducing new features, but we will recoup that effort later on when we avoid having to do refactoring and disentangling of things that have really become too entangled to separate easily. As a review, we can say that cohesion refers to the number and diversities of tasks undertaken by a single unit. And a highly cohesive class is going to model a single entity, and a highly cohesive method achieves a single well-defined task. And this leads on to answers to some typical design questions. So for instance, people will often ask, well, how long should a class be? What's its maximum size? How long should a method be? Do I have too many lines of code inside this method? And if we rethink those questions in terms of some of the design factors that we've been exploring, we can see that absolute length is not really the issue here. It's more to do with issues like cohesion, responsibility-driven design, and coupling. So a method is too long, not because it has a large number of lines of code, but because it's trying to do too many separate tasks that would be better split off into separate methods. And a class is too complex if it's trying to undertake and model too many entities, and it would be better separated out. Again, it's not a case of how many methods there might be in a class. You can have classes with very many methods, but they're all supporting one logical entity, one logical bit of functionality within the context of a program, and that's not then a problem. A program can also be too complex if there's too high a degree of coupling between its units. We've discussed that coupling is inevitable, otherwise entities can't interact, but it's the degree to which each entity is responsible for its own set of data, its own internal implementation, that determines whether the complexity is too high or not. Introducing a high degree of coupling, too much exposure of internal workings of one class to another class, or interference by one class in another class, is going to be the problem. One of the reasons for thinking about these issues of quality is that we have to recognize that programs continuously change, and it's important to allow that change process to happen both as smoothly as possible and ultimately as cheaply as possible. The more effort that's required to make changes because code has been poorly designed, the more that's going to cost an organization that's involved in the change. And quality of code means much more than just performing correctly or performing a task quickly. Often the highest cost is in programmer time to understand and make modifications to code, and so producing code of good quality has long-term benefits. Code needs to be understandable, code needs to be maintainable. The features that we've seen have been that quality code avoids duplication, it displays high cohesion and low coupling. We haven't said much about coding style, things like commenting, naming and layout, etc. But all those things are also important because they aid in comprehensibility. if your code is consistently laid out, if it's well and accurately documented, it will make it much easier for somebody reviewing your code to understand its purpose, to be able to focus in on the parts that they need to work on and ignore the parts that need no attention from them. And there's a big difference in the amount of work that's required to change poorly structured and well-structured code.